So I know a few of you struggled with this lesson, but this is common for students. Don't worry. So I just thought I'd screencast over it, just so you can sort of review it, and it should help you out. So it's about the different statistical tests that you can utilize. So we go over four statistical tests, and there'll be another video showing you how to utilize some of the tests following this. So this branch of research methods is called inferential statistics. So we need this because we need to prove that results are not down to chance. You need to show when you're doing research that you have not fluked your results and it's actually made um, an important impact on sports science. So within sports scientists all agreed that we should use 5% as the accepted level of chance or the accepted level of a fluke. So if you relate 5% from the numbers 0 to 1, 5% is 0.05. Now this relates to something called the p-value. Now the p-value relates to that accepted level of chance of 5%. So what we say in split science is to have a significant difference or a significant relationship, you need to get a p-value of 0.05 or below. So that's what this symbol means here. It means less than or equal to 0.05. What that basically means is that there's only a 5% chance that your results are wrong or that they are due to chance. They test for both relationships and differences. Now this is important because you might be looking for a difference between two groups within your study. So you might be looking at the difference between netball shooting and basketball shooting. You might be looking for relationships. So you might want to know, is there a relationship between shoe size and long jump distance achieved? What's really important about knowing these tests is you need to utilize them next year in your research project also. Okay, so we've got parametric and non-parametric. Now, there's a really easy way to remember the difference between these. So if you think back to your second assignment, we looked at different classifications of data, and there's 6 of them. Well, I just need you to remember 4 of them now. So there's 2 types of inferential tests, and this depends on what data you'll be using. So there's parametric or non-parametric tests, okay? Now, parametric tests utilize interval and ratio data. So ratio data is pure frequencies. So, for example, the amount of basketball shots you scored or the amount of netball shots you scored. Interval is, excuse me, it's like a diving score or like, Strictly Come Dancing. You've got set intervals in between. Non-parametric, easy way to remember the difference between parametric and non-parametric. Look at the first 2 letters here, N and O, and then I've put them in the right order for you, N and O, so nominal and ordinal. So ordinal is like your world rankings, like tennis world rankings, and nominal is grouping everything into categories and counting people within those categories. Okay, so I've changed the SPAG error on this now, so you see it says Spearman instead of Pearson's. Now this is where people got a little bit confused. This map here tells you which test you need to use. So you just need to answer the question. So the very first question you need to ask yourself is, what type of data have I got? So I'm going to utilize the example of our basketball and netball experiment. So with our basketball and netball experiment, we're collecting ratio data. Now, ratio data is parametric data. We've already seen that in the previous slide. So we know we need to utilize a parametric test. So now we go down to the next couple of questions. So do I want to find out if there's a relationship? No, I don't. The whole point of my experiment is I want to find out if there's a difference between netball and basketball shooting. So go to the next question, which is want to find out if there's a difference, which is yes, I do. I want to find out if there's a difference. So we come down. Are you comparing more than 2 sets of data? No, I'm not. I've got netball and I've got basketball, so it's just 2. So I come down to no. Then it says, have you tested the same subjects twice? And this is where it gets a little bit confusing for you. You tested yourself, so you have tested yourself twice. However, you have not done the same thing. So if you did 2 lots of basketball shooting, you would say yes, and you would come down to the dependent t-test. However, because you did netball and basketball as 2 separate things, so no, you haven't tested the same thing twice. So what this basically tells you here is you would need the independent t-test because you've come down, you know your parametric, we know we want a difference, we know we're only doing 2 sets of data, haven't done the same thing twice, therefore independent t-test. And that's all you do to work through it. It's even easier if we go through the other experiments. So let's look at our let's look at our shoe size against long jump. So that's parametric data again, because the type of data we're looking at is interval data, because you got your shoe size, so it's parametric. And then it comes down, do we want to find a relationship? Yes, we do. So we need the Pearson's test. And then if you had non-parametric data, you'd go through the same. So you notice the Spearman's is the same as the Pearson's, and you'll notice the Mann-Whitney U is the same as the t-test. The only difference is that these tests are non-parametric, which brings me to this next table here. So what are they testing for, and what type are they? Well, we know that both the Spearmans and the Pearsons both test for relationships. We've just seen that in the previous diagram. And also that the Pearsons is parametric and Spearman's is non-parametric. Additionally, having seen the previous diagram, we know the t-test and the Mann-Whitney U test for differences. However, t-test is parametric and the Mann-Whitney U is non-parametric. So that's all we got up to in terms of the lesson, but I'll just carry on in terms of this. So you got independent and dependent. So dependent tests the same group, doing the same thing twice, whereas independent tests different groups or the same group doing a different thing. So this is where it relates to the basketball and netball. You were doing a different thing within that experiment. You were doing netball and basketball, which are two different things, which is why you needed the independent t-test. However, you would have required the dependent t-test had you, say, if we collected your basketball data, if I put you on like a 4-week training program with Joe Mills to develop your shooting, and then you came back and did your basketball again, that would be a dependent t-test, because we're seeing if your results have depended upon that 4-week training program from Joe Mills. So this is from last year, so ignore this. We did a different experiment, but as I just explained, for our netball basketball experiment, you needed the independent. So that's the end of that lesson. Hopefully this video helps. If not, just come and see me.